Hi, I'm Laogao. Today we'll talk about a fascinating physics experiment, the double-slit experiment. It's simple, but the results are strange. How you interpret them could lead to amazing ideas, like consciousness shaping reality. Is that how it should be explained? In high school physics, the teacher didn't really cover it, just limited it to glass birefringence. That's how it was taught, I'm sure. The impression is strong. If you think that way, you might have attended the class, right? For instance, the future can alter the past. And also, it can prove the existence of parallel universes. Who talked about these? These are what I'm prepared to discuss today. Actually, the most amazing thing is this experiment. It's not a thought experiment. In physics, many experiments are incredible, most being thought experiments. It's like those paradoxes you think about in your mind. Like if I went back and got rid of my grandfather, would I still exist? And so on. There are many incredible things like that, but this is not a thought experiment. It actually exists in reality. The results of this experiment have been validated by the world's top physicists for over half a century, and the results themselves are not in question. But why is the result like this? As a result, physics couldn't really explain it, so quantum mechanics was created to describe it, not explain it, because it can't be explained. Now, let me introduce this experiment, which is simple and doesn't need any physics knowledge. You just need to have watched our previous episode about light. Around 300 years ago, people debated whether light is a wave or a particle. Initially, Newton said it was a particle because it travels straight and can reflect. It seemed like a particle. But over a century later, in 1801, the British scientist Thomas Young carved 2 slots into an opaque board and shone a beam of light on it to see the shadow on a wall. Through this, he showed that light is a wave, not a particle. Normally, if light were a particle, it would pass through the slits and make 2 bands of light on the wall. But the experiment showed that when light passed through these slits, it created alternating patterns of light and dark on the wall, known as interference patterns, a trait unique to waves. Particles do not have this characteristic. They do not interfere in this way. The pattern is easiest to explain using water waves. If you throw a stone into the water, it will create concentric circles of waves. When these waves pass through 2 slits, they will generate 2 sets of waves. These water waves interfere with each other. Where crests overlap, they become higher, and where a crest and trough overlap, it flattens out. This creates interference patterns behind. This experiment greatly contributed to physics by proving light is a wave, thus the double-slit interference experiment is named after Thomas Young, fully called Young's double-slit interference experiment. Actually, you can do this experiment at home. If you have a laser pointer, place a strand of hair in front of it, and it will effectively split the beam of light into 2. Typically, we might assume that when light strikes a strand of hair, it divides into 2 separate beams, casting merely a shadow of the hair. However, rather than that, it generates a pattern of alternating light and dark on the wall. This shows that the 2 light beams that split interfered with each other. After the double-slit interference experiment 60 years later, in 1861, the renowned British physicist James Clerk Maxwell used equations to deduce that light is an electromagnetic wave, further proving that light is a wave, just like all electromagnetic waves. Then, over 20 years later, in 1887, the renowned German physicist Hertz discovered the photoelectric effect, which proved that light is a wave, but it's a very special kind of wave, and it's unclear exactly what kind of wave it is. Eventually, in 1905, Einstein explained that light is both a wave and a particle, defining the smallest unit of light as a photon. As we discussed before, a normal wave is continuous, like a water wave, which is also continuous. However, the wave of light is not continuous. It comes in segments, so it appears to have particle properties. But it's also a wave, and these small parts are photons. Einstein came up with the idea that light is in these small parts. He didn't actually see it. Back then, there wasn't any equipment to observe photons. Then, 20 years later, the famous French physicist Louis de Broglie suggested that it wasn't just photons that acted this way. All microparticles do, showing wave-particle duality. Things like photons, electrons, and atoms all share this trait. The Duke of Broglie got the Nobel Prize in Physics in 1929 for proving electrons have wave-particle duality too. Then, 30 years later, in 1961, we reached the main topic we want to discuss today, which is when we first observed photons and found them peculiar. Before this, it wasn't too mysterious. Even with wave-particle duality, it might just have wave and particle traits. So what's so strange about that? But when we saw it, we finally realized how incredible it was. What happened in 1961? People finally invented the electron gun, a device capable of emitting a single electron at a time. With this device, people first thought of using it to conduct a double-slit interference experiment. In this experiment, a beam of light splits into 2, causing interference. They thought, if I emit just 1 electron at a time, it's essentially the same as emitting a single photon. Then he wouldn't be able to interfere with anyone. In that case, if I send them one by one through the 2 slits, it should eventually form 2 slits, right? They thought this way and then used that electron gun to conduct the double-slit interference experiment. At first, everything was normal. They emitted an electron, just one electron, and it went bang, hitting the back with a light board on the wall. They emitted an electron, bang, hitting the back wall, passing through the slit and hitting the wall behind. They kept emitting continuously and suddenly found it incredible. Interference patterns appeared at the back, even though they were shooting one electron at a time. He interfered, but with whom? It's just one photon, so for interference, two waves must interact. The physicists running the experiment checked their equipment to see if it was truly emitting one photon or electron at a time. It was indeed emitting one electron, but during the machine check, they found something incredible. Isn't it an electron gun? I can fire one electron, and theoretically it should go straight and hit the backboard, right? I aimed, I wanted to hit here, it should hit here, but that's not what happened. I emitted an electron and it went bang. It went here, I emitted an electron, and it suddenly hit there. Once it passed through the slit, it seemed like it hit something. Bang. It went there, bounced back, forming interference patterns, but it didn't hit anything, not even the slits. Once it passes through, it starts bouncing. So, what's it doing before reaching the slits? Before the slits, it's not moving straight because it's affected by the slits. And the space in between is opaque. If I aim at this opaque area, it might still pass through the slit and hit the wall. Aiming is tough, but with one slit, it's simple. If there's just one slit on the board, it can only pass through that slit and go straight. But with two slits, it moves unpredictably and creates interference patterns, meaning it still interacts with something. So they considered the possibility that the photon might be passing through both slits at once, interacting with itself. After all, no one's interfering with it now, right? It doesn't interfere with one slit, only with two slits does it interfere, meaning it passes through both slits at once. Can a photon split into two and pass through both slits? Actually, it can. For instance, a prism can split a single light beam into 7, showing all colors from red to blue. A photon can split into 2, but between our electromagnetic cannon and the double slits, there's nothing in between. It doesn't touch anything, so theoretically, it shouldn't split on its own. How did it manage to split into 2? Verifying this is not excessively difficult. If we were able to observe the photon passing through both slits simultaneously, that would suffice. We would require an instrument to capture that occurrence. However, back in 1961, such technology did not exist. It was not until the 1970s that an apparatus to detect photon movement was developed, known as a light screen. What does this signify? When a photon strikes a light screen, it reflects, indicating that something has passed through. Consequently, they place these light screens in front of the double slits. These two types of light screens will trigger the detection instrument to alarm when an electron passes through a slit. If the electron passes through both slits simultaneously, both alarms would go off. After installing this detection instrument and starting the experiment, a somewhat unexpected result occurred. Each photon emitted only passed through one slit, meaning only one alarm would go off each time, and it never passed through both slits.
Every time it's through one.
A slit, not necessarily. Even if you aim at this one, it might go through that one. But it always goes through one slit, not two at the same time, so if it doesn't go through two slits, interference won't occur. Yes, exactly, they thought, oh no, how can it interfere if it goes through just one slit? So they kept emitting, and found that there were no interference patterns on the screen behind. What appears are the light spots from two slits, which indicates that when we start trying to find out which slit the photon goes through, it no longer interferes, it changes. If you remove these two detection instruments. If you emit photons again, they start to interfere, and patterns appear. But if you install the detector, it turns into particle-like light, showing two spots on the wall instead of patterns. Is it the detector's problem? Doubt is just doubt. This detection device might have interfered with the experimental process. So later on, various methods were thought of to avoid the observation affecting the experimental results. They even thought of recording it with a video camera without watching it, and after it's done, they would watch the recording. However, they found that as long as the video camera is not being watched, if you try to observe it, it will still not interfere. It will not interfere, and you will never witness how it simultaneously passes through two slits. The instant you observe, it goes through merely one slit. This detection instrument, irrespective of its kind or method of observation, will behave like a particle if you attempt to observe it. As long as you don't try to observe it, it remains a wave, preventing you from ever seeing its wave properties, and you'll never see how a photon simultaneously passes through two slits. In other words, we can never see the side of it that we want to see. After this result appeared, it actually overturned the foundation of science, which is based on experiments. Prior to the double-slit interference experiment, the results of all physical experiments did not change regardless of whether someone was observing. That is, the results would not change whether someone was watching the experiment or not. This was impossible. This also ensures that our formulas can be used anywhere, right? But this light experiment is different. If someone tries to observe it, it becomes a particle. If no one looks at it, it turns into a wave. The properties of light change with human observation, and our observation is determined by our consciousness. Therefore, this results in the objective reality being determined by our consciousness.
What if our...
The nature of consciousness does not allow for other possibilities, but in the future I will give a big... Actually, if we use our thoughts to influence something, it tends to move in that direction. This can be statistically proven. Later experiments were conducted, and in the materialist view there is no direct connection between our consciousness and objective reality. Our consciousness cannot influence objective existence. Whether I'm alive or not, or have thoughts, the universe operates the same. Even if everyone on Earth vanished, the universe would still function. Yet this experiment suggests otherwise. When all humans are present, light acts as particles, and when absent, it acts as waves, showing a shift in the universe. This result might seem magical to many, but for physicists, it's a big challenge. They need to prove this phenomenon is reasonable, otherwise physics would fall apart. So, the famous American theoretical physicist John Wheeler tried to redesign this experiment. To find the cause of this phenomenon, John Wheeler, a master in the field of physics, was one of the leaders of the Manhattan Project, and also one of the main designers of America's earliest hydrogen bomb. Kip Thorne, the physics consultant we mentioned before in Interstellar, was his student. He had numerous exceptional students, and the term parallel universe was introduced by one of them. We will create a special video to present him soon. Additionally, he proposed a single electron universe hypothesis, suggesting there's merely one electron in the entire universe. This electron constitutes all matter and exists ubiquitously at once. It's both you and me, and it embodies the entire universe. Isn't that akin to consciousness?
The universe is a single consciousness.
The implication is that I am also you, yet he brought up this particular point. It's merely an electron, correct? So, in what manner did John Wheeler enhance this particular experiment? In truth, he made the experiment considerably intricate, but to simplify, he relocated the photon's detection apparatus to the rear of the double slit. Initially, it was positioned at the front to observe how it divided into two as it traversed through the slits. He placed it behind because he wanted to know, since you've already passed through the slit, whether you are one or two. After placing it behind, he discovered another extremely incredible thing. Initially, when the detection device was not turned on, interference patterns appeared on the screen without any issue. However, after an electron was emitted through the double slit, he suddenly turned on the detection device before it hit the screen. One electron was detected in a particle state. The screen's pattern changed from interference fringes to two bright spots. But this is impossible because before the detection instrument was turned on, it had already passed through both. In theory, it should have passed through both slits simultaneously, and interference should have already occurred, which was an established fact. However, when we turned on the detection instrument before this established fact was confirmed, it actually changed the established fact from 2 to 1, and it appeared to have passed through only one slit. This is the famous quantum delayed choice experiment. I've simplified it for everyone. The actual experiment is more complex, and interested viewers can research it themselves. Through this experiment, one might conclude that the future can alter the past. This is because the observation happens later, in the future, while passing through the slit happens first, in the past. The idea that future events can change the state of passing through the slit implies that the past is altered. In other words, it can foresee the future. He's aware someone will watch later, so he can choose early whether to interfere and get ready. What benefit does this give him? The only advantage for him is that we can never see him going through two slits at the same time. It can conceal this fact. We can only ever see one photon passing through one slit, but in reality? But actually it does. If it didn't go through two slits, judging by the phenomenon, it should go through two slits, otherwise it wouldn't create interference. If it's that clever, how would it let you find out? Oh, that's true, but even if we discover it now, there's no way to prove it went through two slits. It's just a guess. We can only speculate that you can't observe it. We think it's a physical object, an objective, lifeless thing that doesn't have consciousness. In theory, it shouldn't change according to our consciousness. But now it's proven that they seem like an extension of our consciousness. They always twist according to our consciousness, and whatever we want to see, we can't see.
It's like suddenly discovering that an objectively existing fact can actually change.
Moreover, as our consciousness changes, it reacts even faster than we do, always ahead of us. It can anticipate the result we want to see and then not show that result. We want to see it pass through both peaks at once, but we can't. This experiment shows the future can alter the past. Or you could say this photon has the ability to foresee the future, and it already knows what is going to happen. This phenomenon not only occurs with photons and electrons, but all fundamental particles have this characteristic.
Nevertheless, this future occurrence had already been predetermined in the past.
Indeed, based on your comprehension, it had already been determined at that specific moment, although it had not yet been put into action. It was merely a concept, yet he was already aware of it.
And this idea cannot be changed anymore.
It can't be changed anymore, so it doesn't have any meaning. You can't change the past, but how did he know my thoughts? That's the question, right? When I emitted this photon, I had already decided to observe it at that particular spot, which should also be considered an objective fact.
It's a fact you just eat.
You won't starve, you say, as history and the future are set. It cannot be changed. This can be considered cause and effect, right? This can indeed be explained and understood this way. Electrons are something we usually think of as small balls, because when we observe them, we always see them as small balls or points. But in reality, when we are not observing them, they are neither small balls nor points. It is a misty, shapeless entity. The photon is a characteristic in that you don't see it as energy. You don't know where it is, and now we know about wave-particle duality. It exists in elementary particles, atoms, and even molecules, shown by the double-slit experiment. Later tests with large molecules showed this effect too. However, this phenomenon is very clear in elementary particles, as it can be shown with just a double slit, while large molecules need many double slits. It also requires multiple diffractions for this effect to appear. Anything unseen might have a dual nature like glass, though its display varies. Larger objects show this less clearly, while smaller ones show it more. If molecular or larger structures are unseen, they exhibit this phenomenon. This suggests that on a macroscopic level, although we don't see phenomena like the microscopic world, such as the future changing the past, or the subjective shaping the objective, it might just be beyond our perception. There is no way to not observe it, because as soon as we see it, it is already determined. It's like the example they often use about the moon. The moon is there because we see it there. If none of us on Earth looked at the moon, perhaps it wouldn't be there, and if any one of us sees it, it's fixed in place. Fixed there to ensure that you can only ever see the moon in that form. You can't see it in a misty form. The universe is the same way, like distant stars. Before we see them with a telescope, they might not even exist. So when we do see them, they suddenly exist, and you can't prove whether they really existed before we saw them. How does physics explain this phenomenon? The current mainstream attitude is that the microscopic world might just be like this, although it's hard for us to understand and completely different from our intuition, and we can't explain it with macroscopic physics. It is just like that. So, a specific branch of quantum mechanics was established to explain this phenomenon, not to interpret it, but merely to describe and illustrate it. Whether it makes sense or not, that's not important. That's the mainstream attitude. However, this attitude is quite unscientific. Science is about seeking reasoning, pursuing the underlying principles. So if we have to use our existing ideas and theories to explain it, there are a few possibilities. First, it might be true.
The subjective influences the objective, but it's not fully proven that it's subjective determination. The objective is just considered primary.
Observational consciousness impacts the objective. Yes, it affects it like this. Another thought is that the objective might not be lifeless. We often assume the objective world lacks consciousness. Things like photons seem without consciousness, but maybe they all have it. Whether it is a single consciousness or dispersed in various objects, they should have some kind of consciousness, and they can have a certain reaction to our consciousness. Or perhaps they are constantly monitoring our actions to ensure that our behavior does not conflict with this world, preventing us from seeing the true essence of this world. It feels like they are guarding some kind of secret. Why can't we see it? I don't know. But another possibility might explain this. Time doesn't exist. If time doesn't exist, then there's no past, future, or present. They're all the present. So changing the future also changes the present and the past. In that case, changes are normal. However, the idea of time not existing is hard to grasp, and many things are tough to explain. Indeed, we live in a process of change. We can indeed feel it.
The time has come. At the very least, we are.
Yes, it can be realized, right? We still have a lifespan, don't we? If you say time doesn't exist, that's hard to understand. Now, these three possibilities, any one of them is revolutionary, and at the very least, they have a significant impact on current science. If not handled well, they could completely overturn science. Because whether it's the subjective deciding the objective, the future changing the past, or time not existing, all of these would lead to the overthrow of physics and even all of science. Actually, science being overturned is a minor issue. The key issue is the fundamental nature of this world. If we ultimately discover that this world is not real but virtual, how we face our future lives becomes a significant problem, doesn't it? At this point, the upheaval of science is not a big deal. Now, a more reasonable explanation has emerged. I think this explanation makes the most sense, which is that we have never observed one photon becoming two photons passing through two slits simultaneously. Whether the camera is in front or behind, we only observed one photon, so it is possible that it has always been this one photon passing through one slit, not two. Why do we insist that it might pass through two slits? It's because interference occurs. So, is it possible for one photon passing through one slit to cause interference?
I was just on the verge of saying yes.
Did you uncover this particular issue? Please share your thoughts. I'm all ears.
Is there a situation where you think someone can't do something, but they actually can?
Yes, there's a chance indeed. This doesn't overturn science. It can even be explained scientifically. I think this makes sense, just like you said. He might have this ability. Yes, why he has this ability is very important. Let me explain. Based on our current observations, whether the camera is before or after the double peaks, we have only observed one photon. Is it possible that this single photon really just passed through one slit and not two? And what exactly did it interfere with?
The value of everything. Not yet.
Almost. Let me tell you what it interfered with. Actually, there is a possibility now that before the photon passes through the two slits, it is uncertain which slit it will go through. This creates two possibilities. It has the potential to go through this slit, and it also has the possibility to go through that slit. At this moment, a parallel universe formed. Sure, it might not pass through and hit the cardboard, creating three parallel universes. One where it goes through the left slit, one through the right slit, and one where it doesn't pass through at all. We can only see one universe, the one we observe. It doesn't go through the right slit, and after passing, it interacts with something.
And one more.
A parallel universe, the feelings from the guy going through the left slit in that universe, and we can't see him. After his interference, our bang hit the wall, and his bang hit his wall. This creates a feeling of interaction with a parallel universe because information doesn't disappear. The possibilities through any gap don't vanish, so the feeling of interaction with the parallel universe becomes inexplicable. Initially, no, because now causality can prove that parallel universes must exist since information doesn't disappear. But the outcome determines that possibility, and it hasn't disappeared anywhere. Now it's said it can only be in a parallel universe, like dark matter or dark energy. It interferes with something real but invisible. It's the interference with the parallel universe within dark matter and the feeling with another self in the parallel universe, happening when we don't use detection devices to see it.
It will have several parallels.
Universe pairs form.
Parallel universe, however, once we proceed.
When we observe, the very moment we attempt to understand the outcome,
Parallel universe confirmed.
it will disappear between them. We don't know about the disappearance, but the interference between the parallel universes will disappear. No way to interfere. Without observation, there's a connection between parallel universes. Once observed, the connection breaks. We can only see the structure of our world, which means that
We can no longer observe parallel universes, right? But we are also parallel.
just one of the three possibilities in the parallel universe.
Only three possibilities. If it is us, then
In our case, this day would generate countless possibilities, and when choices are made, many parallel universes would be created. Maybe the reason we can't observe parallel universes in the macroscopic world is because we see everything in our world. We can only see this universe. The interference with other parallel universes is cut off. If there is an area we cannot see, like inside a black hole, we cannot see it. So this area might interfere with the black hole in the parallel universe, and the result inside is uncertain, with all possibilities. This is Murphy's Law, which says if something can happen, it will happen. It's just a matter of whether it happens in our universe, and in parallel universes, the other outcomes of our world's results will definitely be different. The result is that in our universe, if it goes through the right slit. So, in the parallel universe, this guy definitely went through the left slit, or perhaps he hit the cardboard and didn't pass through. Now, to address your previous point, you asked if you're doing well in this world, does that mean you're not doing well in a parallel universe? It's not necessarily the case, because choices constantly create branches. When you face a choice, it creates a branch in your current state, and it's unrelated to branches that happened a long time ago. So countless parallel universes. Every day of your life will generate countless parallels. Yes, especially when you buy a lottery ticket, it can create millions or even tens of millions of parallel universes. Just one wins the prize. There isn't a winning one, only one where you win the prize. You might wonder if there's a way to make this universe the winning one, right? Because there will definitely be a branch that wins. At the moment, it seems unlikely, because as I told him, no matter when you observe the result, the lottery result, the outcome is actually determined at the time you buy the ticket. In this universe, it's pretty much known that you didn't win, and it also knows you will definitely observe it in the future. You have clearly demonstrated that this particular outcome is definitive, and it cannot be changed. Which universe will actually manifest in this universe remains uncertain at present, but there exists a method to bring the potentially victorious universe as close to you as possible. Let's discuss the information principle next. It's linked to this topic, but the double-slit experiment doesn't directly prove Western medicine principles, as there's no direct link. However, the fundamental nature of the world shown by the double-slit experiment suggests psychological principles could be effective.
The speed of the universe's expansion will definitely be faster with more lotteries. Many surviving?
Are you referring to the current 43 out of 6 or 46 out of 6 lottery games? But only one branch of the parallel universe can win, but you will definitely win. I think it means that everyone who buys will win. Every person who buys will win. Jet Li once starred in a movie that talked about if the other versions of you in parallel universes die, the energy of the you in this universe will increase. Interference will reduce, you know? It will increasingly lean towards the direction you desire.
Got it.
because you don't branch out. If you branch out, you might have some bad results or something like that. After branching out and winning the lottery, you come back here and then he would definitely want to get rid of me, right? Ah, yes, in that movie, Jet Li travels to parallel universes to eliminate other versions of himself, becoming stronger, but... It seems to make some sense, but this is too much. It's impossible.
It feels like a paradox because he is purchasing a lottery ticket. At the same time, he's no longer in the same parallel universe as me. Yes, it's because I didn't buy it, and he's already in the next branch. Yes, the logic of that film doesn't belong to just one.
The logic of how many parallel universes will be created for him is pretty simple. At first, there might be about 100 of these parallel universes. Ah, perhaps the actual parallel universe is significantly more intricate, but it is conceivable that when you disappear from other parallel universes, your branch might not continue developing there. This energy will, in a relative sense, concentrate more in your direction.
Then try to make fewer choices.
Making fewer choices is an option, but if you don't choose at all, you'll have no opportunities.